Hi, my name's Andrew Corney. I'm the product director here at Sefaira, and today we're going to be talking about 3 early stage design workflows made easy. There are over 400 of the world's leading firms using Sefaira, architects, engineers, and consultants, and Sefaira is used as an early stage design tool to help people do design analysis during schematic design, concept design, in the UK often referred to as REBA stages 1 and 2. So we're a very specific product, and today we're going to be talking about how you can use our software to make those stages of the design more effective for you. We'll look at the sorts of early stage design studies that are popular, and in particular, we at Sefaira spend quite a lot of time doing research of the industry and of our customers to understand the sorts of things that people do during early stage design. And then we try to make our workflows and our software geared to helping people be able to do those sorts of studies. So we take a very workflow first approach to the development of our software and think about what people need to do and then try to make the software able to do that as effectively as possible. We'll then dive into 3 examples, an early stage energy cost saving study, an early stage roof lighting study, and an early stage passive design study. Design teams all over the world want to consider building performance as early in the design as possible. This is something that we hear all the time from our customers, from prospects, from people in the industry, from conferences. Wherever you go, we know that people want to be involved more early in the design process. Why do they want to be more involved? Well, it's when the key design decisions are being made. Most of the big decisions are made by the end of schematic design. So the big decisions about the building form, usually the HVAC system's decided, a lot of the envelope strategies are decided, space plan layout is decided. So if you use performance-based design analysis to help inform those decisions early, then it can help avoid rework later on. And of course, most firms are trying to differentiate themselves from each other during these processes. And it's when your clients are really watching the most. Many projects start off with all of the design principals and partners participating in the schematic design process, and then delegating later stages of the design to other very capable project management team leaders. But most of the key decision makers, the people who are going to decide who to hire on the next project, will be watching during the schematic design, during the early stages of a project. So people want to put their best foot forward and show that they're really forward thinking in terms of their design approaches. What are some typical early stage design tasks? Many of you on the call may have participated in some of our surveys over the past couple of years. This was a pretty comprehensive survey we did of the industry, which asked people who does specific tasks. We gave a list of different studies, and we asked respondents to tell us whether they do those studies during schematic design. And as you can see, there are a whole range of different studies along the bottom here. The 3 ones we're going to look at today were 3 of the most popular. One of them was an energy conservation study. One of them was a daylight study, and one of them was a natural ventilation study, which we're calling passive design study. But almost 50% of our customers, or 50% of the people surveyed, were trying to do natural ventilation studies, and well over 50% were doing energy conservation studies during schematic design. So very popular studies that people are trying to do, and we wanted to present those today and share how to do those in Sefaira. How do we understand an energy cost-saving study? We like to think of things as user stories. So what are you as a user of the software or as someone who's in the industry thinking? A common requirement might be, I'd like to see which energy strategies, reduction strategies are most effective so I can get our design on the right track. So we want people want to compare. People want to look at options A versus B versus C. Often people want to look at ABC versus an indicative baseline like an ASHRAE 90.1 baseline as well. So they can make sure that their design's moving forward in the right direction at schematic design. In terms of daylight, people want to understand, a classic user story might be, I'd like to get a feel for how effective envelope improvements will be at providing better daylight to this design. And really that's to understand whether or not they're worth including it in the design or proceeding forward with the design, and also whether it's worth, or whether that can be, they can be used to convince a client that that's worth doing as well. Because a lot of the time, architecture especially is about telling a narrative and helping to communicate that narrative to the client. The other user story that we often hear is, I want to know what passive design strategies are needed so that I can have a building without mechanical cooling. And I know a lot of people on the call are probably calling from the west coast of the States, or potentially in Northern Europe. And many people in those regions and in other parts of the world as well, looking at residential projects that may be able to avoid the need for mechanical cooling. And so what is involved? What do you need to do as a design strategy to be able to avoid the need for mechanical cooling? We'll look at how you can start to look at that in Sefaira. So these studies are really popular. This is what we understand people want to do during the early stage design process. But there are things that make this hard today. And, you know, for those of you who don't know me, I am Australian, so I like to think of things as boomerangs. And you can see that the solution space for early design is something of a boomerang. On the y-axis, we have speed, and on the x-axis, accuracy. And the solution space tends to be clumped in options which are either fast but fairly inaccurate, or slow and more precise, I suppose. So a lot of people use rules of thumb during early stage design. But if I'm talking about adding shading onto a building, how can I use rules of thumb to communicate how effective that's going to be at improving the design? It's fast, but it's pretty much guesswork. A lot of rules of thumb are really just making stuff up anyway. But people are using their intuition and their experience. So I guess the more experience and the more intuition that's been built up over time, the less likely it is to be made up. Many intrepid engineers especially like to then dive into spreadsheets. And what happens with spreadsheets is they do tend to provide a sense of accuracy, but in many cases just end up taking more time than rules of thumb, but are based ultimately on rules of thumb, and so don't tend to be that much more effective at actually conveying real results. Of course, there's also compliance analysis software. There are tons of great software programs out there that are used for very detailed energy modeling and daylight analysis. And those software tools, by their very nature, require people to put a lot of information in before you can get an output. And so they're slow. They might be more accurate at calculating an ultimate result, but they tend to be quite slow. And of course, if someone's doing that and it doesn't follow someone else's intuition, then they might just make the results up anyway. So what Sefaira is trying to do is Sefaira is trying to offer a solution for early stage design that is both fast and accurate enough for you to be able to proceed with confidence in your design approach. We're not a compliance tool, and we're not trying to be a compliance tool. We're trying to help you make good decisions early on in a fast and efficient way that meets the budget that you have to spend at those stages of design. So the reasons why we are fast is because we work very hard on an interface and a workflow. The geometry comes from SketchUp, you'll see that. And the reason why we believe we're accurate is because we use open source tools such as Energy Plus and Radiance as our engines. So that's enough about Sefaira. Let's dive now into some of these use cases, and we'll talk first about the energy cost savings pathway or strategy exercise that we're going to look at. And so thinking about this user story a bit more, what we sort of imagine people would like to do is, I'd like to communicate my energy efficiency strategy to my client. And that might be, if you're a consultant or an engineer, you might be telling that to your architect. Or if you're the architect, you might be trying to tell that energy efficiency strategy to the end user or the end client of the project. Why are you trying to do that? Well, they might be very interested in how much energy the building's going to use. They might be very interested in the overall sustainability of the building, or they might be interested in seeing how you're thinking about delivering a compliant design that achieves a certain amount of performance against typical benchmarks. So you want to understand what strategies that you're looking at and investigating during schematic design, which strategies are going to have the biggest impact. Let's say you're interested in understanding or getting a guide against your overall energy saving against ASHRAE 90.1. If we had to live without some initiatives, or we have to ditch some ideas that we have, we may have had a workshop and a whole lot of ideas have been put on the table. How do we decide which ones of those aren't any good so that we can put them to bed? How do we have some resolution around them? And then what percentage of energy could I get from a renewable energy system? And that might also feed into a preliminary estimate of LEED credits for energy savings. Oops. So we're going to start with this simple model. And we're using a simple model because, an energy model, although you can use other models that have been built in SketchUp, an energy model doesn't necessarily have to be very complicated. So I've drawn a sample building, which is perhaps a realistic early stage model with some zones drawn inside, but otherwise it's a fairly basic building form, and we'll have a look at that. So I'm going to go into SketchUp now. I've got my building here. And for this exercise, we'll do a project in Chicago. So I'm going to take my building design and I'm going to upload this into Sefaira. Now, what I'm going to do today is I'm going to start by showing you some of the ways that how fast it is to set this project up in Sefaira and get the project going. But then I've built a lot of the studies that we're going to look at already, simply so that I can make sure that we have time to get through all of the content that we want to look at during this presentation. So we're going to call this the webinar, Energy Options Study, and we'll leave it in Chicago. And we'll just assume for now that it's an office building project. Now, Sefaira takes SketchUp models and converts them into Energy Plus geometry. We use the floor plates predominantly as the way to generate the geometry for Energy Plus. And what you can see here is Sefaira kicks off an energy run straight away for you whenever you upload a model. And really our philosophy for any sort of analysis study is that people want to be able to get to an answer very, very quickly. We want to eliminate the need for you to have to jump through hoops before getting an answer, because some customers we know need an answer in 15 or 20 minutes. Of course, you can continue to invest more time in the software and more effort to make sure that your answer is more and more accurate. But the goal of Sefaira is to make it easy to get answers as soon as we possibly can. So in a few minutes, we've been able to take our SketchUp model and create our first option. Now, what we'd like to do is we'd like to create a LEED baseline. So I'm going to make a copy of this initial model, and now I'm going to call this the ASHRAE baseline. Okay. And for this model, I'm going to change the zoning strategy to be the zoning strategy that I drew in my SketchUp model. I'm also going to turn on a glazing override, because the ASHRAE 90.1 standard generally expects you to have 40% glass for all of your facades. So we're going to have 40% glass for all of our facades, for argument's sake. So there we go. And now we'll also make sure that our envelope materials match ASHRAE 90.1 Climate Zone 4. And we're pretty much ready to go, so we can now kick off a run and have an ASHRAE 90.1. The ASHRAE 90.1 baseline system is, for the building of this size in Chicago, is a VAB system, which is the baseline system that's been applied here. So it's a pretty good start for us on this project. While that's running, I'm going to now start taking the second option, and I'll also apply the zoning strategy, one zone per room, that we have. So we can see now that the building has the zones that we've drawn in the SketchUp model. We'll call this the initial design. And we'll also, for argument's sake, start with the ASHRAE 90.1 baseline materials for this project and start updating the analysis for that. And while that's running now, I'm going to think of a few other different things that I might like to compare. So I'll make a few options, and then we'll have a look, once these results come out, at what our building energy breakdown looks like and where we think we can make improvements to the design. Okay, cool. So first of all, we'll have a look at the energy breakdown for our initial model. And we can see now where the energy use is broken up inside the building. Now, this is in terms of raw energy, but because we're looking at ASHRAE 90.1, we might be a bit more interested in cost. So we're going to look at cost as our starting point. And as you can see, when we go from usage to cost, the cost of the heating goes down dramatically, and that's because we're using natural gas for the heating system and the heating cost is lower. So one thing that sticks out quite high to me is the lighting energy. This is probably the biggest chunk of the energy use that we have an impact on, this bright yellow piece here. And I suspect there might be an opportunity for me to reduce, I want to try one strategy, which would be to reduce the lighting energy of my project. So I'm going to take this second option now. I'm going to call this better lighting. And I'll change the, go into the space use section and change the lighting power density and change it from 0.9 watts per square foot to 0.7 watts per square foot. Okay, so I've got, I'm going to reflect a lighting design solution that's better than my initial design and run that. I'll also look at this option, the third option, and perhaps I'm also looking at better glass because the cooling energy from the building was substantially, was quite a high proportion of the energy as well. So I'll come in and I'll change the solar heat gain coefficient of the glass down to represent a better glass. And I'll also change the U value of the glazing assembly to represent something that's a bit better. And run that. So as you can see, it's pretty straightforward to start layering design options on top of them, on top of each other very quickly without too much effort. What I'm going to do now is I'll go to the page that I have. Whoa, hang on. Where I've done some work already in creating a series of options that we might want to compare. So you can see that we have the ASHRAE 90.1 baseline, an initial design, an option where we've looked at better glass, an option where we've looked at more insulation, improving the lighting, adding internal blinds, changing to a central plant HVAC system, and changing to a VRF system. So these are all the sorts of strategies, or a typical list of strategies that someone might want to study during early stage design. And to get that sort of list of options out, today, if you were someone who wasn't used to doing very much energy modeling, or even if you were someone who was a practitioner who wanted to be able to do a study like this very quickly, to generate this list would take quite a long time. In Sefaira, it's designed to be very fast so that you can get that information very easily. Now what I've done on the energy tab is I'll pull up the energy results. I've selected cost and I've picked compare concepts. So quickly what you can see is we can see against the ASHRAE 90.1 baseline, which of these strategies tends to be more effective than the other, and it provides a percentage saving for each of those strategies against the ASHRAE 90.1 baseline. Now these are only the savings that each of these individual strategies might provide, but at least now we can see in the ballpark how effective some of these different strategies are at improving the energy use of the building. And if we want to tell a slightly more focused story, of course, we could look at just the cooling energy and say, okay, well, how are these specific strategies going at reducing cooling in particular versus other design solutions? And you can see that because our initial design had a bit more glass and because more insulation will hold the heat into the building, they're actually increasing the cooling in the building, whereas, of course, our better glass has had a nice big impact on the cooling energy there. So immediately now, if we had a workshop and we've come through and generated an option like this, I could share this energy strategies report with my team members. Everyone else could come in and have a look. If there were leftover strategies from the workshop that we wanted to also add in, we could add them in. And then we could align on which ones we wanted to proceed with or move forward with. And it's a very fair and equitable way, but a very quick way for the project to start to make progress and to whittle away the energy solutions that we don't want to apply on the project. Now let's say we want to fast forward the project a little bit and we actually want to now present an energy reduction strategy to the client. What I've done is I've done a very similar exercise, but instead of adding lots of clones and just changing one thing in each of them, I've changed multiple aspects of the clones. So what we'll start with here is the initial design, and then adding improved lighting as the first strategy, better glass as the second strategy, more insulation as the third strategy. Okay, and now what's quite fun about this approach as well is that you can see, you can see here how the energy for the building gradually decreases over time. So, so we can quickly start to show how our energy strategies layering on top of each other are going to be improving the overall design of the project. And if we have a project manager, for example, who's very, very keen on us having, for example, a VRF system in this instance, which wasn't the most effective solution, we can still communicate there in the context of this energy strategy. And if it sticks out like a sore thumb, so be it. We can also come back and say, you know what, we all agree that we don't want to do that solution, remove it from the list, and it'll come out of the table in a few moments. The other thing that's nice about this compare concepts approach is a lot of the time you'll want to look as well at, hang on, I'll just refresh that grid. A lot of the time you might be interested in looking at renewable energy as well and understanding the impact of renewable energy. And one of the things that's complicated about renewable energy is when you look at an energy pie chart, you want to see the energy use of the building. But of course, a renewable energy system is going to offset part of that use, but which part is it's fairly agnostic. So we've added an option at the bottom, which is our last strategy, which is usually in the energy reduction strategy process to add a PV system. And there's an energy mix layer where you can see where your total energy is being used from. So in this case, this is the proportion of energy coming from gas, this is the proportion of energy coming from electricity, and this is the proportion of energy coming from renewable energy. So in this instance, we have 21% of our project energy in terms of energy use coming from renewable energy. But in terms of cost, which is what we're interested in for, say, ASHRAE 90.1, we can see that 27% of the cost of our project comes from renewable energy. So very quickly we can ascertain that outcome. And we can also see the results with or without renewable energy. So now if I select the original design, and go back to my chart, cost, energy mix compared, and drill into the solar PV, you'll see that our final design solution is 35% better than ASHRAE 90.1. So we very quickly communicated our design solutions and how we've ended up at a strategy that's 35% better as a cumulative solution. Now, Sefaira, what's great about Sefaira as well is that it gives you the opportunity to output these results into graphs. So now not only have I done the analysis, but I can generate slides that go straight into a slide deck like this. So in the first instance, we looked to see what the key uses of energy were in the building. We saw that lighting was a big part of the building usage at 18%. So we can start to tell the story. We used a reduction strategy to turn that to reduce that lighting, perhaps some LED lighting in parts of the building. That reduced it in the first instance. Then we looked at cooling, which was the next highest element. Perhaps we looked at monthly energy use to see where in the building, when in the building energy was being used. Perhaps it showed us that we needed to apply more insulation for winter heating. And then as at the end of the report, we generated an energy cost graph showing the options that we were considering and how they all compared with each other. And then ultimately a workflow where we went through all of our different options and came up with a solution at the bottom that would lead to a 35% reduction in energy against our ASHRAE baseline. And you can see how each strategy has contributed to that saving along the way on the project. Now this exercise, these graphs are all standard outputs from Sefaira from those graphs. They're not screen grabs, and this would take just a few moments to be able to output these graphs from the web application. Let's take some time now to look at something a little bit different. We're going to look at a different sort of schematic design study that people might be looking at, which is a roof daylighting study. So I'm looking at a building form, and I'm kind of interested. It's got a big floor plate. It's a low-rise building. How could I consider different roof lighting strategies for my project? If I wanted to compare different strategies, which ones are going to have the biggest impact? How would they compare in terms of the amount of light that we get over the year? And you know, again, thinking about the sorts of codes and standards and benchmarks that are used to compare different options down the track, how would we be likely to fare on those sorts of standards? What about the impact of these different options on energy use? How is that going to work? And then ultimately, if I want to pick one of these design solutions, if I want to propose a solution that's going to have some sort of extra architectural elements on the roof, then I'm going to need to tell this story to the project team, and I'm going to need to have a good narrative behind me to be able to sell the story. So here's our building to start off with. It's a 3-story medical office building, again, that's been built in SketchUp. I'm going to open the building in SketchUp because we're doing okay for time so far. So here we go. I've got my medical office building, no roof skylights. Okay, so here's my building, and the nice thing about daylight analysis in Sefaira, we'll just switch the daylighting analysis on for now, is that we can consider the daylight analysis of the building within the 3D environment, either in Revit or SketchUp, but you know, I love SketchUp, so I'm going to be doing it in SketchUp today. There's an annual daylight measurement, which is basically the daylight autonomy calculation, and it'll tell us the percent of the floor area that achieves a certain light level. So we've set the target to be 300 lux, and we're interested in seeing how much of the floor plate achieves this annual light level on the floor. Now this simulation takes about 2 to 3 minutes, so rather than wait for it, I'll let it run in the background and show you the results. But I'll go back to the presentation so we can see what the results show. We can see here very, very visibly how the center of the floor plate, as would be expected, really, I mean, you don't need daylight analysis necessarily to know that the middle of the building is not going to have any daylight. But at least now we can start to quantify where we have areas where we don't have very much daylight at all. And this is our problem space that we'd like to solve with this schematic design study. So what I've done is I've created 4 different SketchUp models. You could do this with scenes or with different SketchUp models. It's completely up to you. And there are going to be 4 different design options that we'll look at. One which is our starting point. The second one where we've added some skylights to try and bring some daylight into this part of the building. A third piece where we look at adding some clerestory or some windows, some north-facing clerestory windows. And then the final solution where we'll add both the windows and the skylights to see what happens to the building design. So let's see if we've got the results back. No, we still don't have the results back, so we'll just let that run away. You know, obviously with an hour, I think it's more interesting for us to get through to show you what you can do with the software rather than to wait for all of the results. So we'll go through and show you some of the results that came out of this analysis. So that first analysis showed us that that we had this fairly dark patch here in the building that needed to be addressed. The skylights have provided some assistance in terms of showing us that we were able to bring some light deep into this space and resolve the light issues here. But of course, those skylights aren't even enough to bring full skylight across the floor plate, let alone bring light deeper into the space. And when we look at the option where we just have the clerestory roof options, you can see that we were missing light from where these skylights are being provided. So we have a final option where we have both the clerestory glazing and the skylight options. And then that brings us to a point where we have between 75% and 100% of occupied hours having 300 lux on the top floor plate. Let's see if the results have come back yet. Yes, so we can see here the initial set of results contextualized on the building. And of course, if we're interested in seeing overlit and underlit as well, we can see which spaces are getting too much light and which spaces aren't getting enough light. So while it's been running as well, the other thing that I've done is I've uploaded these 4 options to Sefaira. So I've taken the different building forms that I have, which are the building without any skylights, and of course the other options, including the building with skylights and with the roof lights. And I've taken each of those building forms, so 4 different SketchUp models or 4 different scenes, whichever way you want to do it, and I've uploaded them into a project in Sefaira. So I've called this the roof lighting study. And I did a couple of things after the models were uploaded into this project. So when you upload a form into a project, you can add it to an existing project. So each of these different buildings, although they look the same, are each of the different options that are described here. So we uploaded the different forms into the same project. And so now I can compare each of those different forms very easily to see how the design's affecting energy as well. And when the building forms were uploaded, there were some default material properties. I improved the glazing somewhat, the roof glazing down here to make sure that I thought I did. I made some improvements to roof glazing, and then I also made some allowances for daylight, reduced lighting in the center zone on the top floor from the solutions that provided more lighting into that building. And as you can see here, we can use the same energy breakdown chart to then start to communicate and investigate how much of an impact those different strategies have on lighting energy. So you can see the yellow is the lighting energy, and there is an impact in lighting, but perhaps not as much as we might like it to be. Or heating energy with the extra glazing in the roof, how much is having the skylights has barely made an impact, but the clerestory obviously allows a lot more heat to escape out of the building. Or we could look at cooling energy, because even though the clerestory is shading the roof from direct sun, what we thought was a good design may not have ended up being so great, because we're still getting a lot of solar load during the peak of the summertime as the sun comes around to the north side of the building. And if we're curious about that as well, we can see here on the top floor in the center zone for the two options, we can see that for no roof lighting, our center zone 1 has no solar load and only 16 BTU hours per square foot of peak cooling load. Whereas the option where we have the extra lighting, roof lighting, has substantially more load and a substantial amount of solar gain and glazing conduction coming into that space. So all of this information can help us to start to pull together a story and understand whether or not we've designed the clerestory as well as we possibly could, whether we want to make further changes to that. We might still decide that it's worth having the system because it's really important from a health and well-being perspective to get light into the center of the building. Or we could use this strategy to continue to look at different options or form alternatives for that building. Second. So again, very easily, these graphics can be very easily downloaded from the application. So I don't know. Oh, maybe I've changed the building form. Whoops. Let's see here. If I can get this back. I shouldn't have changed my building model in the background. I think it's going to come up anyway. So you can see here from this is from the building without any of the roof glazing. That's predominantly underlit. But whatever graphic I have, whatever view I have set up in Sefaira, and of course the view is mimicking the SketchUp view, I can always grab images and download them as a snapshot and put that into my report, which is what I've done here. So very quickly I can assemble a story, a narrative which says these are our design options and this is how they perform. These are our options in terms of energy and this is how they compare in terms of annual energy use. So very quickly pulled together a report that I can then submit at the, or slides that I can present to the team for further discussion and analysis. Finally, I want to talk a bit about passive design. We have lots of customers who design houses, and you know, I'm a huge fan of designing houses without air conditioning. I've been lucky enough to live in a lot of milder climates, and I've never had to have air conditioning. And I think it's great if we can help people design houses that can avoid the need for cooling. So some of the questions that come up in these sorts of design processes are, how do I know if my window openings are big enough? And this is a really key question for any architect designing a building that's going to be passively designed, whether it's a house or a school, whatever it is. Because usually, on a lot of instances, the consultants may not be available in the project yet, or they may just simply not have the fee to go through lots of different design iterations on window sizes and opening sizes. And so what we wanted to do was we wanted to make it easy for an architect to test quickly whether or not the window openings were big enough for natural ventilation. Then, of course, the next question is, assuming the windows are big enough, how comfortable is it going to be? Is this building going to meet what we agreed with the client would be an acceptable temperature for the space? And if the first design doesn't achieve that, then how much will passive design strategies improve the comfort of the project? So I thought, you know, it might be good to go through a little bit about why natural ventilation design is hard, and it is hard. When you're designing a mechanical system, anyone who's designing a mechanical system, it's very straightforward. You input a 3D model and a set of design properties, click simulate if you're actually using a simulation engine, and I hope that you are, but I'm not just using rules of thumb. But if you are using a thermal simulation, click simulate, and the software tells you the HVAC sizing that you need to hit the desired temperature, and your design is resolved. And that happens in Sefaira because in all of these instances, we've already told you straight away what the HVAC design airflow is for, and the cooling equipment, and a lot of other HVAC equipment sizing information for the building design. So it's a pretty straightforward workflow. When you're doing a natural ventilation system, it's a bit trickier because you're working towards a comfort solution. You can't say achieve this comfort solution. So essentially, you have to do input the design that you think is going to achieve the comfort solution, simulate, see whether the building's comfortable enough, decide if it passes or fails, and if it fails, decide what changes you want to make, and then resimulate. So there's a lot more boxes, a lot more arrows, and that can mean a lot more time and complexity to the design process. And that's why it's important to have good methods and processes for doing good natural ventilation design. We introduced a free area tool a few months ago, actually about 6 months ago now, and it's been really interesting how a lot of people aren't aware of how you can use free area as a strategy for getting started with natural ventilation very quickly before doing any thermal comfort studies. Free area is essentially and free area ratio is essentially a way to test how open the apertures in any room are as a proportion of the room area. And generally speaking, if you have apertures that are 5% open, then that means if the free area of the aperture is 5%, or the opening size of the aperture is 5% of the floor area, then you can expect to get good natural ventilation. There's essentially what is an observed free area comfort relationship, where as free area gets to about 5% of the floor area, comfort and ventilation performance increases, and then at about 5%, there is no further observed improvement in comfort with further increases in free area. Lots of standards and benchmarks actually use free area as a way to decide whether or not you've prescriptively complied for ventilation compliance. So BREEAM, Australian Standard 1668 Part 2, and Title 24 all allow free area calculations as a means to demonstrate prescriptive compliance with the ventilation standards for a naturally ventilated building. Sefaira makes it very easy to do free area calculations, and we'll look at this nest residence project as a starting point. I'm going to show you, let's just shrink the Sefaira window for now. I'm going to show you two models that I've started with. So my first model was this nest residence model, which is a real project designed by an architect in Sefaira. And you can see that this is a house with a whole lot of windows and zones. When this was uploaded into Sefaira, the results showed that the free area, you can do a very quick free area assessment of each room. So in the 3D model, all of the glazing is considered to be openable unless you tag it as fixed. Actually, I'll show you quickly how that works. The plugin has what's called an entity palette, which lets you see how you've defined different components in the building. And you can see here that this is glazing, this is a wall, and so we've got a whole pile of glazing that's been applied to this building. When we upload the model, then we can set what the free area ratio of that glazing is, and then it will test each of the zones very, very quickly to see whether or not it passes the 5% floor area requirement. So in the top floor, the two rooms we cared about, we passed. But on the bottom floor of that building, you'll see that this bottom right left-hand corner room here fell short of the free area requirement by a substantial amount. So we only had 5 and a bit square feet of free area on that glazing, where we needed to have a lot more area than that in the model. So this was a very, very quick way to understand what the free area requirements, what the free area problems with the model were. So we went back in and we made a second model. And in the second model, we added a new window on the east facade, sorry, of the building, as a means to add more free area into that zone. Re-uploaded it to the same project with the extra window, and clicked the free area button to test the free area of the building. And you'll see now that that zone passes the free area target. So you can take all of your SketchUp designs and options and upload them into Sefaira, tag glazing as fixed or openable, set the openable proportion of the glazing, and then very quickly check whether or not the free area is good enough for natural ventilation in the project. And now with free area good enough in all of the rooms, we can now proceed on a comfort study knowing that each of the rooms in the building has enough opening to be able to be naturally ventilated properly. Because the worst thing to do is to waste time trying to look at passive design strategies to make a zone more comfortable when the real problem is that your windows don't open enough and you've forgotten about that. So what I did in this project then is I started to look at comfort metrics. So we had an agreed set point range with the client between 68 degrees and 79 degrees effectively. This is a project in Seattle. And so Sefaira runs the comfort calcs using Energy Plus. Works out hourly what the comfort in the building is. And then we can see how many zones in the building failed and how badly they failed. So we can see here in zone 2 that it was only comfortable for 95% of the time, and sometimes it was too hot and sometimes it was too cold. So very quickly we can get a sense of how the zones are going in the building and which ones are the most problematic zones. And then so we started to look at different strategies to try and improve the comfort within the building. Better glass and external blinds were two of the best strategies that we considered. So when I look at, and then the other thing that as well was we had a conversation with the client and said, well, we don't just want to meet dry bulb temperature targets, because even though that's a good target to try and achieve, we might want to achieve an operative temperature or ASHRAE 55 target. Given that they had quite a low set point target for ASHRAE 55, we set a PMV bottom threshold of 1.5 and an upper threshold of 0.5, and tried to work towards that target. And as you can see, the zones were still failing with the original design in this circumstance as well, both being too hot and too cold on the PMV scale. Once glass was added, the results got better, and of course once an external blind was added, the results were better still. So what I did was I took screen grabs from Sefaira to show the results. So this is the free area story. And then looking at dry bulb temperatures, the base design for the ground floor, low E glass as a strategy made these two zones more comfortable, and then applying external shades virtually improved the comfort in terms of temperatures across the whole of the ground floor. And the same outcome happened as you'd expect, with temperatures getting better and also resultant temperatures getting better. We were able to communicate how rooms were getting more and more comfortable with the progressive improvement of different strategies, different envelope strategies. Now, PMV comfort is quite difficult to calculate normally. What we've tried to do here is to make this workflow very easy. So not only can you get the results straight away and visualize them across the whole floor plate, you can be able to tell a story very, very quickly in terms of how different strategies are performing on your project. And in summary as well, as you saw in the website, we were able to look at unmet hours and what percent of the building was passing or achieving the comfort criteria that we wanted, and ultimately 50% represented the living spaces that they most cared about. So in short, why would you want to use Sefaira? Hopefully what we've shown today is that we're really focused on the early stage workflows that are most typically done by architects, engineers and consultants. We're very keen to provide for you ways for you to do the sorts of studies that you need, taking a very study-focused approach to rather than a feature-based approach to designing our software, and focusing on what you need for an end-to-end experience. Sefaira is very, very fast and easy to learn. Many of you, I'm sure, already know how to use SketchUp. If not, you may know how to use Revit. So the 3D modeling process is very straightforward. And then to get the model into Sefaira and then start using it is also very easy. So it does require some motivation in terms of wanting to know what you want to study, but it's a very gentle and easy way to get started doing energy analysis on projects. And because we use Energy Plus and Radiance, our results are reliable and can be used to get a good read on how your project's going to go. So that's the end of my presentation today. And there's 5 minutes left, so I guess we can see if there are any questions and maybe try and answer some questions. I don't know if Sumeli or anyone else on the staff there wanted to read any of the questions out, because I haven't had the chance to look at them. Whoa, lots of questions there. A few people had asked questions about audio. Are there any specific questions?
There was a question. Hi, Andrew. There was a question about the Energy Plus connection that we have with our analysis software. I think you just answered that, but you might want to speak directly to that question. So it was Mehdi Zahid. He said, "Thanks for the presentation. Could you elaborate on the relationship between Energy Plus and Sefaira, if there is any?" And he was also asking about an educational version. So yeah, I would focus on answering that Energy Plus question for Mehdi.
Okay, yeah, hi, thank you. Yes, so Sefaira does use Energy Plus. You can download the IDF file from any of the simulations that we have straight from the application. So you'll see here there's an export IDF button on the screen, and that export IDF button gives you the IDF that was used for the analysis. So yes. One thing that I think that's unique about Sefaira that does make our life difficult for us is that we do try to compensate when we think Energy Plus has not done something right. That may be creating a rod for our own backs, but that means that we do take feedback on whether the results are right, and we have made some workarounds and improvements, what we believe are improvements to the software, to accelerate bug fixes that haven't been addressed yet by Energy Plus. So we do see it very important to be providing the most accurate results that we possibly can. But in most instances, you can reproduce the results by downloading the IDF and running it in Energy Plus. Similarly, the daylight results are generated either using Radiance or DaySim. We create an analysis grid and then either use DaySim to do annual calculations on the analysis grid, or use Radiance directly to do point analysis within that analysis grid, and then reflect that in the rendering that we generate on the model afterwards.
All right.
I think there was also a question in natural ventilation: is Energy Plus running the bulk airflow analysis? Yes.
Exactly.
Yes, Energy Plus uses. We use the full air movement network feature in Energy Plus, and so it does do a full natural ventilation study. We only support side ventilation at the moment. We don't support cross ventilation or buoyancy ventilation solutions. But yes, it does do a proper bulk airflow analysis within Energy Plus. There's 3 minutes to go. Let me see if I can answer a couple more questions. There was a question, how accurate have your findings been compared to what has been built? We have not done any comparison of our studies on real life projects. We have tried to benchmark our software against the results that people have got later stage in the project using other simulation tools. And many of our customers are very happy with what we've been able to do in terms of providing results that give comparable guidance to what they get from compliance-based software later on in the design process. We kind of see that as our goal really at the moment, to provide something that's going to give you the right direction on the project. But we're not at a point yet in our development where we're focused on achieving predictive performance of energy use. There were questions about weather data. We have a network of weather data that we have in our own database. Much of it is from the Energy Plus openly available weather data. We also have a substantial amount of data that's been taken from weather analytics, but you can upload your own weather data to the application, your own EPW files, and use them if you want to. So there's no constraint on that. Let me see. PV data, we currently use the vanilla PV module in Energy Plus, and you can control things like the efficiency and obviously the size and orientation of the panel, but you cannot select specific brands. I think, how does Sefaira build zones? In SketchUp, you just need to draw lines on the floor plate to have the zones. So in this SketchUp model here, let me see if I can open the SketchUp model. It's easiest to show. Just going to move the questions out of the way. You'll see here that in this particular model, the lines that appear as zones are just lines that we draw on the floor plate. So we take each of the floor plate components and convert that into a zone. In SketchUp, we use rooms as the way to define zones. So as long as you draw the rooms, that's what you'll get as the zones. If there's any questions we haven't answered, I think what we'll be doing is going out to everybody and replying to all the questions that have come on the website directly. Thank you very much for your time today. I hope this was an interesting and useful presentation. It's great for you all to be here, and we look forward to talking to you and seeing you again in the future. So thanks very much for your time, and look forward to speaking again.